Hello everybody, this is Miss Burge. This is our first unit and we're going to go back to numbers. If you recall the number line you learned in elementary school and middle school, that line is made of many infinite number of dots, and each dot that's so tiny, so invisible, represents a number, and together they form a line, and that line we call it the numbered line. And another way to call that line is called the real numbers. And as you can tell from here, the real numbers are composed of two parts: irrational numbers and rational numbers. So since we are high schoolers now, we're going to start with the rational side. So when we talk about numbers, we actually want to think back about how numbers came about. They actually originally came about in the Persian area when the Persian merchants had the needs to start counting. And if you recall, when you were little babies, or if you see little babies on the street when they're trying to learn how to count numbers, they always start counting like this: 1, 2, 3, 4, 5, 6, so on and so forth, until they can count to 100, right? So all of these numbers that you first learned when you were a baby, we call them natural numbers. And that's what the merchants in the Persian Gulf area used when they're adding up the money that they earned through the trading. And then they got a little bit smarter. So they said, oh, what if I run out of money? And that's when they said, okay, now we're going to do this. We're going to add a symbol, and and that symbol is 0. And we use that symbol to represent nothingness, no money, right? So for whole numbers, we still have all the natural numbers we discovered, but we're simply adding a big fat 0 to it. And that was the biggest discovery back when. And so now these merchants can not only make money, but sometimes when they run out of money, they also have the number 0 to represent that. So then unfortunately some of them lost money. So they said, what am I going to do if I lose money? I made $3 yesterday, but then I didn't make that much money, but I lost some money, and now not only I'm empty, I also owe other people money. So this is when they started to think about another system, and now they're adding the negative numbers. So we still have our natural number 1, 2, 3, 4, 5, and then we have the whole number. We added 0 to it, right? So these are the numbers we know. It's called whole numbers. Then they said, I'm just going to use a negative sign and make it balanced on the left-hand side of that number line. So then they created negative numbers. So far, all of these are integers, right? So again, we started with the baby numbers. We call them natural numbers because it comes to so natural with us. Then we added 0 to it, so now we call them whole numbers. And then we added negative numbers, and those are called integers. So together, sometimes it's not quite correct, but sometimes I even call integers, the negative integers, I call them negative whole numbers. That's just a colloquial term of illustrating that part, but more scientifically we call the negative numbers and the whole numbers all integers. So at this point, as you can see, the numbers are fairly easy to understand, right? They're whole numbers or negative whole numbers, or they're 0, or 0 is a whole number, I guess. But sometimes we talked about fractions. You and your siblings get into fight. So you start to see things like 0.5, 1/2, 2/3, maybe even 0.666. It goes on forever, and sometimes we do 0.677, we put a bar on top to indicate that the 7 gets repeated. We can even do square root of 16, which comes out to be 4. So the square roots is another weird thing. So all of these numbers are rational numbers. So another way to say this, rational numbers are all fractions and decimals that end. So in other words, if I have 0.5, so it ends there. I have a fraction 1/2, it ends there. And I can have negative 0.67, it ends there. And I can have square root of 16, it's 4, right? So all of these can be converted into a decimal point that have a repeated pattern. So that's called rational numbers. Sometimes rational numbers is a little bit challenging to understand. It's actually easier to understand irrational numbers. If you think about Princeton's favorite day, March 14th, is called the pi day, because pi equals a long number, a long decimal with no end. It doesn't repeat. It's a mystery, right? So it just keeps going on and on and on and on. It never ends. And if you use your calculator, maybe figure out what is square root of 2, and you will see that in all the numbers behind the decimal point, they don't repeat. Another example I use is square root of 101. And put it in your calculator, you will find the same thing. There's no patterns to it. They are crazy. These are called crazy numbers. They are crazy. That's why we call them irrational numbers. So by contrast, the predictable numbers that ends at a certain point or repeats itself, we call them rational numbers. So you add all of these numbers together, we call them real number system. So let's look at this one. This is another chart that illustrates this. It's exactly the same thing. Natural numbers goes from 1 to infinity. Whole number includes all natural numbers and 0. Integers include natural numbers, whole numbers, and the negative whole numbers. So that makes integers. And rational numbers are the fractions, square roots, all the numbers that can be converted into a decimal point with a certain repetitive patterns. And finally, we have the crazy numbers, square root of 3, 5, 7, 8, negative square root of 5, and pi. You could have yi in here. You can have lots of numbers in there as long as they have a decimal point that does not have a pattern. None of the digits repeat itself. And if you add them all together, that is your real number system. Okay, so let's look at how we can how we denote those numbers. So for real numbers, we use R, and I often write R with 2 marks there, 2 lines there, and that R equals all numbers you've learned so far. For irrational numbers, we use I, and in the example before, I used square root of 2, I used pi, negative 101. These are my crazy numbers, right? And rational numbers, I use Q. So that's universal in the math world. Q represents rational number. And remember, these are numbers that it can be converted into a decimal point. Either it ends at a certain digit or it has a repetitive pattern, a repeated digit. Integers, we use Z. And remember, integers includes negative whole numbers. So you have to illustrate that. And whole numbers is just 0, 1, 2, 3. That's the easiest. And the letter we use is W. And natural numbers, we just use N. That's an N. Sorry about my chicken scratch. Let's see. That's an N for natural numbers, and that's the baby numbers we all learned when we were tiny little babies. So that's the classification, and we're going to do more practices in class.